Hey there, everyone. This video is going to show you how to look at parallel lines, transversals, and naming a bunch of angles. Let's go. What we need to start with is the definitions for parallel lines. So parallel lines are two lines that are always the same distance apart and they never touch. So just a quick example of what that may look like here and here. For notation, what we tend to use with parallel lines is these little arrows. If you have more than one set of parallel lines, then you may add additional arrows to represent which lines are parallel to which. A transversal is a line that cuts across two or more usually parallel lines. So for example, if I start with a set of parallel lines like so, and I take another line and I cut and go across those two lines, this third one that I just brought in would be called the transversal. When we have a set of parallel lines being cut across with the transversal, what we get is we have all of these different properties with angles. So what we're going to talk about is what all of these different angles are called and how we refer to them. So it's going to be a whole bunch of definitions. All right, first let's talk about some definitions. On the right side, I have a set of parallel lines being cut with a transversal. I've decided to label all of the angles with lowercase letters so that we can refer to them when we're going through these definitions. First thing that we need to start with is supplementary angles. Supplementary angles are angles that have a sum of 180 degrees. An example of this from my diagram here on the right would be A and C. So what we look at is that A plus C would have to add up to 180 degrees because those two angles create a straight line. A different example would be G and H. G plus H would give me a sum of 180. Complementary angles we don't talk about very often when it comes to parallel lines and transversals, but they are angles that have a sum of 90 degrees. And for this one, I don't actually have an example of that in my diagram on the right. Because this transversal doesn't cut across the parallel lines at an angle of 90 degrees, then none of those angles will be 90. The next 5 definitions that I'm talking about are very specific to when we are talking about a transversal cutting across a set of parallel lines. Using these 5 angles, we can actually use them to identify if two lines are parallel. Let's start with just looking at what are corresponding angles. So I'm just going to kind of talk about them and then put examples in each of these boxes. So corresponding angles are angles that are kind of in the same section of, I guess, the intersection of the transversal with the parallel lines. It's easier to just talk about as an example. So A and E in my diagram to the right are an example of corresponding angles. So A is in kind of the top left corner of this intersection. E is in the top left corner of that intersection. If two lines are parallel, then A and E will have to be the same. Next, what we want to talk about is the alternate interior angles. I've labeled some to the right. This is an example of alternate interior angles. So they're on the interior of my diagram and they're on opposite sides of the transversal. They're on alternate sides of it. So the name of these angles sort of just kind of makes sense with where they are. They're on the interior and they're on alternate sides of the transversal. Once again, very similar to corresponding angles. If these two lines are parallel, then C and F will be the same. Next, let's talk about alternate exterior angles. What we could probably guess is where they are. Again, they're going to be on the exterior, so we're looking at A, B, G, and H, and they're going to be on alternate sides of the transversal. So an example of this would be A and H. Just like the other two angles, if these two lines are parallel to each other, then A and H have to be the same. Next, what I want to talk about are opposite angles. Opposite angles aren't necessarily correlating, or I guess just talking about with parallel lines. Opposite angles are just saying that they are on the opposite side of each other. So an example of opposite angles would be A and D. And I'll label them here for us, A and D. Another example could be F and G. In terms of kind of helping us prove if two lines are parallel, opposite angles aren't really going to help us, but a good property to know about them is that they will always be the same. Next, we'll talk about co-interior angles. Depending on the textbook that you're talking about, the website you're looking on, co-interior angles might also be known as consecutive interior angles. So once again, we're looking at the interior, but what it means to be co-interior or consecutive means that they're on the same side of the transversal. So an example of this would be C and E. If two lines are parallel, then what we will always notice is that C and E are going to be supplementary angles. Which again means that they are going to have a sum of 180 degrees. Last thing to talk about here is not really to do with parallel lines and transversals directly from what the picture I have here, but what we always want to remember is that angles in a triangle will always have a sum of 180 degrees. Knowing this property will help us with some of the word problems. What I want to talk about is next is how we can actually use these definitions to identify if two lines are parallel or not. Let's look at a few examples. The example we want to look at is answering the questions, are lines A and B parallel? We want to use the definitions from before to identify if two lines are parallel. So let's first look at the first example. What I notice is I have two lines, A and B, I have a transversal, C, and I have these two angles labeled. Even though A and B may look parallel, it's not enough to say they're parallel just by looking at them. We would need some way of proving that these two lines are in fact parallel to each other. When I look at 100 here and here, these two angles are going to be considered alternate exterior angles because they're both on the exterior of the parallel lines and they're on alternate sides of the transversal. So C is my transversal. What I know about alternate exterior angles is that they have to be the same in order for two lines to be considered parallel. Because 100 and 100 are the exact same, then this means that A and B are parallel to each other. So this symbol represents the fact that two lines are parallel to each other. So you can use that symbol if you'd like. Let's look at the next example. Here what we have is A and B. We're trying to show if these two lines are parallel. So right now C again is acting as my transversal line. And what I'm trying to identify is if A and B are parallel to each other. These two angles that I've labeled here at 120 and 80 are going to be co-interior angles. In order for these two lines to be considered parallel, what I need is that these two angles need to be supplementary, meaning that they need to add to 180 degrees. When I add 120 to 80, I get 200 degrees. 200 degrees is obviously not equal to 180 degrees. So what this means is that A and B are not parallel. A way we can write this with symbols is that A is not parallel to B. These two examples show you how we can use our definitions to identify if two lines are parallel or non-parallel. I hope this video helps you. Let me know if you need any help.